Okay. Hi all. Welcome to Next Generation Classes. Next Generation Classes is an online e-learning company. We provide classroom trainings as well. We are located in Hyderabad. Currently, we are providing cutting-edge technologies like Mongo database, and development and administration course, Node.js web application development course, Big Data and Hadoop development course, and Selenium automation testing course. And there are many other courses like AngularJS, UI, HTML5, and UI Stack, and Spring and Hibernate, and J2EE, and Core Java, and there are many other courses are in pipeline. And why exactly next generation classes you have to choose is, all our trainers are real-time professionals. They are working professionals who will be teaching with us on, the weekends as well as in the weekdays, either in the early mornings or in the late nights, which is comfortable for all the professionals. So, and all our classes gets recorded and will be pushed into the cloud, and the recordings will be shared with you so that you can refer it anytime. And in addition to that, we will be getting a real-time hands-on experience. Daily assignments will be given, and the code snippets, whatever the softwares, everything, it will be shared with you. And trainers will be anytime available for you, your support. You can drop an email to them one day before if you have any doubt, and they'll be always free to explain whatever the problem you are facing. Okay. And today we are having a Hadoop development, Big Data and Hadoop developer course demo. And with me we have a real-time Hadoop developer, Surya, with me. So I'm passing the control over to Surya. Surya, you can, I'll be giving you the control. You can start your demo. Okay.
Sure.
Yeah, Surya, you can go ahead.
Okay. Okay. Hey everyone, this is Surya, and today I'll be talking about what Hadoop is and what big data is, and it's like more or like a demo part wherein we'll be introducing you with the course contents and what would be the takeaway from this particular course and how long this course gonna be and what is a plan for this particular course. And yeah, like I told, I will be the trainer for this course delving deep into Hadoop. And I'm a HortonWorks certified developer. And basically, to give you a brief introduction of what sort of work I do on daily basis, I work on data analytical part of credit cards, wherein we will be using Hadoop and its related ecosystem components for fraudulent detections, as well as credit card balance calculations, or it can be on for cycle and the credit card cycle end, or probably month end cycles. We will be calculating the balances, and we will do some analytics on the customer data to understand the customer behavior, which would help in turn to the bank to increase their business. So this is our day-to-day activities, and we use Hadoop for data analytics, offline data analytics, Hadoop and its ecosystem components, and we also use DB2 and Vertica as part of real-time data analytics. And we do visual analytics on top of our data present on Hadoop, for which we would be using Tableau. Right? But this course is primarily going to concentrate on Hadoop and its related ecosystem components. So to start with, what is big data? Because whenever you hear about the word Hadoop, you'll always hear about the word big data. Because Hadoop and big data always goes hand in hand. Yeah. So what is big data? Big data is collection of larger data sets in the range of petabytes, exabytes, zettabytes, which is probably not in the normal range of gigabytes or megabytes. right? So big data is basically collection of larger data sets in the range of petabytes, exabytes, zettabytes, or even more, or probably some thousands of gigabytes or something. And yes, what do we do with this big data? What is the purpose of having big data, and how do we do some analytics, or where do we store this big data? This purpose of having big data is, see, nowadays if you look at the trend of data production, if you take New York Stock Exchange, it produces 12 terabytes of data per day. If you look at Facebook, it produces 25 terabytes of data per day. United Health Organization, it has almost it produces almost like 15 terabytes of data per day, which is its experimental data. Okay, so every organization, British Telecom is producing 9 terabytes of data per day. So this is like their transactional data. It can be transactional data, or it can be some experimental data, or it can be some social networking data, anything. When they have this huge data, and if they store it somewhere, they can use this data to understand or increase their business by doing some analytics on top of this data. And this data can be structured, semi-structured, and unstructured. So when you have this huge data, where do you store this data? Definitely not in RDBMS. Because when these organizations like Facebook, New York Stock Exchange, or British Telecom, all these organizations if they are using some RDBMS to store their data, definitely down the lane, probably after 2 years, there won't be any physical space left, an inch of physical space left to add few more hard disks to accommodate this big data. Because this traditional system stores the data as it is without much of compression techniques. So your data, when it is going very huge, you got to add some external hard disk to your cluster, which might occupy entire space in the data center, which may not allow furthermore to add few more hard disks, right? So that's one reason why big data cannot be stored in some traditional systems. If at all we are able to store this big data in traditional systems, there will be a lot of constraints on top of your traditional systems, like these are relational databases. When there are relational databases, they will have relations between the tables, right? That means you got to join tables when you have to retrieve some data, when you have to run some analytics on top of your data, which is going to make your situation more pathetic when you have to perform some analytics on top of an RDBMS. And apart from that, they'll also follow the normalization techniques, norm 1, norm 2, norm 3. So you cannot have some redundant data, which is not possible when you are trying to store your big data. So that means big data is something which cannot be stored or analyzed on traditional systems. So what's the alternative? So that's why there are many tools available in the market, like we have MongoDB, we have Cassandra, we have columnar databases like Vertica, and we also have something like Hadoop. So I would say Hadoop has an edge over all these columnar databases or NoSQL databases. Why? How Hadoop is different from other databases or other frameworks? Because Hadoop has an edge over these databases or frameworks with the way it operates. How Hadoop operates creates an edge for Hadoop itself. Let's see that. So to tell you what Hadoop is a software library or a framework which is written on top of Java, which allows distributed processing of large data sets across clusters of computers using simple programming models. So you'll have to understand what is this distributed processing of large data sets? How is it able to achieve that? And how about this simple programming models? So these two are something that we are going to concentrate now. Then we'll come back to this definition once again to understand what Hadoop is. To tell you about HDFS and MapReduce, I'm going to explain HDFS and MapReduce with some generic example. But what is this HDFS and what is this MapReduce? Hadoop usually comes with a distributed file system called Hadoop Distributed File System, which in short we'll call it as HDFS, and a programming model called MapReduce, which we'll call it as MR. So let's understand what this HDFS and what MapReduce is. Let's say I have a client who has given me a task to perform or to lift some 100 bricks from one place to another place. So when he has given me a task of lifting some 100 bricks from one place to another place, I have recruited a guy who can perform this task for me. And this person has told me, hey Surya, I'm going to take 100 minutes to lift these bricks from one place to another place. That means on an average, he is going to take 1 minute per brick. So when I conveyed this back to my client saying that I'm going to take 100 minutes to complete this task, he said, no, you'll have to achieve this in 10 minutes. So I don't have any other go. What I did is I've recruited 9 more people. So totally I have 10 people in my hand. I've distributed this work among all these 10 people and I've asked them to work parallelly so that I can achieve this task in 10 minutes. I've asked each person to take 10 bricks so that at the end I will be completing this task in 10 minutes. So when I have to talk about Hadoop distributed file system, it's a file system which is group of different file systems. It's not a single file system. HDFS is group of different file systems which allows you to work distributedly, which helps in achieving parallelism. So rather than completing a task in 100 minutes, we are able to achieve that in 10 minutes because we have distributed the task and achieved the parallelism. So that's how HDFS works. It's a group of file systems which works in a distributed manner. But one thing that you'll have to recognize here is, while distributing the task among different file systems, we'll have to have some criteria or a mechanism based on which we will split the task. So when I have to talk about MapReduce, I have 2 technical paradigms. One is mapper and another thing is reducer. Mapper is something which splits the task and maps among different file systems, right? And when I have different file systems working on my task, my end result will be stored in different file systems, right? I can have a part of my work stored in one file system, part of my work in different file system. So when I have this, I cannot ask my client to collect the end result in bits and pieces. So I'll have to combine the result and give it back to the client. So that part will be done by reducer. When mapper is splitting the task among different file systems, after they complete the task, reducer combines the result and give it back to the client. So Hadoop usually comes with 2 different things. One is HDFS, which is a file system group which is made of different file systems combined together, where we usually store the data. And we have MapReduce, which does the data processing, for which you got to definitely provide your programming logic. And on which technology do you provide the programming logic for MapReduce? It can be either in Java or Python, or it can be C, CPP, Perl, any high-level programming language. But Java is the most preferred programming language for writing MapReduce in Hadoop. It's because Hadoop is a framework which is written on top of Java. So if you read this definition once again, Hadoop is a framework which is written in top of Java that allows distributed processing of large data sets across clusters of computers using simple programming models. So this clusters of computers is nothing but HDFS, and this programming models is nothing but MapReduce. So when someone asks you what Hadoop is a framework written on top of Java. Okay, we have understood what Hadoop is and how Hadoop operates with the help of HDFS and MapReduce, right? So being a Hadoop developer, what is the role that you'll have to perform on day-to-day basis? You will have to write MapReduce logic either in Java or in Python or any other programming languages preferred by your organization. On top of that, you will have to operate on HDFS, for which you'll have to learn HDFS commands. And apart from this, you also do the data analytics using Hadoop ecosystem components. So there are different Hadoop ecosystem components like Hive, Pig, HBase, Scoop, Flume, and this list adds to the, there are few more ecosystem components which gets listed to the Hadoop ecosystem components. Being an open source, there are many ecosystem components available, but whatever I've listed like Hive, Pig, HBase, Scoop, Flume, Oozie, right? These are the most important ecosystem components that you will have to work on for sure within any organization. So I will take this demo now to explain about what course contents that we will be dealing with and what would be the takeaway from this course. So we have the course contents available in this nextgenclasses.in. I'll just walk you through the course contents that we would be covering in this course. This course would be for 40 hours. It can be daily 1 hour, right? And the takeaway from this course would be you should be in a position to work on Hadoop related activities independently post this session. And you also should be in a comfortable position to give certifications on HortonWorks or on Cloudera. So to drive this course in this way, we have designed this course to be purely practical. To make it practical, we will be working on different case studies at the end of every section. During the sessions, we will be talking about practical part, and again, at the end of every section, you will be having a case study to work on, which helps you gain confidence or get hands-on to work on Hadoop related activities independently post this course. And we will also give you quiz at the end of every section, which helps you in gaining knowledge while giving the certification for Cloudera or HortonWorks. So we'll start with the course on understanding Hadoop and big data, and then about Hadoop architecture. We will also talk about, how different the old architecture is and what are the advancements in the new architecture. When I say old architecture, it is Hadoop 1.0 architecture. And when it is a new architecture, it is Hadoop 2.0 architecture. In our course, we will see how different these two are and what made Hadoop 2.0 come in the place of Hadoop 1.0 architecture, how different they are, and what are the limitations in the old architecture. And to give you hands-on, we will build our own cluster, a pseudo-mode cluster on every laptop. I'll give you the software to build that, as well as some reference materials which you can refer while installing the cluster. We will talk about how do we install the cluster and how do we configure the cluster so that you will be in a comfortable position to understand about different underlying concepts of Hadoop while installing your own cluster. And once we build our cluster, we will talk about HDFS commands in detail. When I have to talk about HDFS commands in detail, you are supposed to learn Linux, because Linux and HDFS commands are almost in sync. So as part of this course, we will also have a Linux session for 1 hour so that I can brush up all the Linux basics, which would also help the newbies who would be attending this course but who are not aware of Linux at all. Yeah, at the day 1 itself, we will be providing you the materials for learning Linux. We will also at the end of every day session give some case studies either on Linux or on core Java, which makes you comfortable while we enter into HDFS part so that you easily work on HDFS and its related commands. Because we will have to work closely with Linux to automate some tasks on top of HDFS. At the end of HDFS command section, we will have a quiz, and we'll also have a case study, which is nothing but building some custom script using HDFS and Unix commands. And we will also develop, after HDFS commands, we will enter into MapReduce part, which is using Java. We will dig deep into different concepts of MapReduce. We'll talk about MapReduce programming and how do we develop some advanced applications using MapReduce API. At the end of this MapReduce course, you will have a case study to perform as well as a quiz which gives you some real-time exposure on how you can expect some questions on your certification, because MapReduce is a major target while you are giving the certification. Most of your questions would be coming from MapReduce and different phases of MapReduce. And we will definitely talk about something called streaming, which is nothing but MapReduce using some other programming languages like Python or something called R or any other machine learning languages. So we'll have some couple of sessions on defining MapReduce using Python, which is nothing but streaming. And after we are good with MapReduce, like I told, we'll have a quiz on MapReduce section, and then we'll jump into Hive, which is Hadoop ecosystem components. So we will discuss Hive from ground zero to a level of some proficiency on data analytics using Hive. Hive is basically a data warehouse running on top of HDFS. So we will have a case study as well as a quiz on Hive. Then we will jump into a data flow language called Pig. Again, we'll start from basic commands of Pig to a level of how do we transform our data using regular expressions on top of Pig. Once we are good with our case study and quiz, we will enter into Scoop, which is an SQL import and export utility. We'll discuss about different scenarios in which Scoop is applicable and different commands that we use as part of importing and exporting data using Scoop. Then we are going to talk about HBase, which is a NoSQL database, and we are going to discuss about all the important concepts that you will have to learn as part of NoSQL architecture, which helps you gain some confidence not only with HBase but also some working knowledge on MongoDB and Cassandra, because at the end of the day all these are NoSQL databases who comes under NoSQL family. Then we are going to discuss on Flume, which is an reliable and aggregating system which can move the data from different data sources to Hadoop. So we are going to discuss about how do we build some configuration files on top of Flume to make this data fetched from different data sources to Hadoop. At the end, now that we have discussed about different ecosystem components and MapReduce and HDFS, how do we schedule all these ecosystem components or HDFS or MapReduce? We should definitely have a scheduler. So we are going to discuss about Hadoop's inbuilt scheduler called Uzi, and we'll also discuss about something very important called Autosys, which is a widely used scheduler for scheduling jobs on top of Hadoop. Yeah. So with this, our course will end, and we will have some case study at the end which gives you overall picture on all the ecosystem components that are listed in this particular course. So the takeaway from this course, like I had already explained, it would be you will be in a comfortable position to work on any Hadoop related activities post this course, and also you should be in a position to give either HortonWorks or Cloudera certification. Yeah, so that's it from this demo. Thank you so much.
Okay, I believe that's a nice course about nice introduction about Hadoop. What are all the courses? What are all the topics? We are going to cover. We had a good understanding, I believe. Okay, in order to reach us, you can mail us at support@nxtclasses.in, or you can call us at 8374793949 mobile number. And if you are looking for classroom training, you can reach us. We are located in Banjara Hills, road number 12. You can give us a call and we will give you the details. Okay. And you can also like us on, we are available on Facebook, LinkedIn, and YouTube. You can, like and keep getting our updates. Okay. Thank you.